A little while ago, I came across this device on Taobao. At first glance, it looked very complete with a surprisingly strong feature set. So let's take a look at the specification. It comes with a 3.5-inch display, and it's a capacitive touchscreen. As I looked more closely, it became obvious that this thing is far more complete than you'd expect from something that's called a toy. And then there's the price. This device cost $33 US. Yep, 33, not 330, no 3D printed case, no screws, no hassle. Plug it in, power it up, and you're good to go. That's when it really started to get interesting for me. So now let's break down the hardware and see what's under the hood. First, the most noticeable feature, the 3.5-inch screen. And this is important. It's not one of those old resistive touchscreens. Instead, it uses an ILI9481 display combined with a GT911 capacitive touch controller. What does that mean? It means you can interact with it directly using your fingers. Tap, swipe, drag. No stylus required, and the user experience is a full generation ahead. The resolution is 480 by 320, which makes it a very reasonable choice for running LVGL or building a dedicated control panel. Next, let's talk about the brain of the system. At the core of this device is an ESP32 microcontroller. Wi-Fi and Bluetooth are both built in, so there's no need for a network cable. That makes it perfect for things like controlling peristaltic pumps, time-based automation, or connecting to KHG systems. Honestly, it's not missing features. The only thing it's missing is your imagination. Alright, next up, let's go over the software installation and setup and see how we actually start using this thing. Okay, first open your Arduino IDE, then go to Preferences. Take a look at the sketchbook location. This is the directory where the Arduino IDE stores your libraries. Make a note of this path, we'll need it in a moment. Next, let's install the required libraries. Follow the on-screen instructions and open the board's manager. You'll need to install ESP32 by Espressive Systems version 3.3.6. In my case, it's already installed. If you haven't installed it yet, you'll see an install button instead. When you see that button, take a deep breath, be brave, and click install. Next, we'll continue installing the required libraries. Again, follow the on-screen instructions and open the library manager. In the search field, type tft_espi, then select and install version 2.5.43. After that, we'll install LVGL the same way. Search for LVGL and make sure to install version 9.4.0. This is the latest version, so we're going straight to the top. Now, let's extract the files you downloaded earlier. After extracting, you should get a folder named v9_7_lily_13. Open it, and inside you'll find 3 folders. From there, copy the LVGL and tft_espi directories into your Arduino IDE libraries folder. When prompted, overwrite the existing files. We already talked about where the Arduino IDE libraries are located earlier. If you don't remember the path, just rewind and check that part again. Once that's done, go back to the v9_7_lily_13 folder. We're now ready to flash the firmware. Click on v9_7_lily_13.ino and the Arduino IDE will open it automatically. Here, we need to make a small adjustment. On line 31, the value of API_EAPK needs to match your KHG EDAP key. You can find this key in your KHG interface under System Setting. Think of this key as an access token. It allows external modules to read data from your KHG system. Next, take a look at line 32. API_interval defines how often the data is read. It's currently set to 30 seconds, but you can adjust this as needed. During testing, I usually set it to 10 seconds, and once everything is stable, I change it to around 3 minutes. Follow what you see on the screen and adjust the settings carefully. The key points are board set to ESP32 tab module, flash frequency set to 80 MHz, partition scheme set to UJPP3M, no OTA 1 MB SP, PS RAM set to enabled. These settings must be selected correctly. If any of them are wrong, the program will not run. Finally, click Upload and the Arduino IDE will start flashing the program to your ESP board. The first upload may take a while. The total time depends on your computer's performance. In my case, it took about 5 minutes. Similarly, if everything goes smoothly, after the upload is complete, a beautiful screen will appear. Next, scan for networks, select your access point, enter your SSID, KHG IP, and port, then hit connect. Once the Wi-Fi connection is successful, press set to save these settings. From then on, every time the ESP restarts, it will automatically reconnect. Alright, that wraps up this video. Enjoy exploring your device. Thanks for watching. Next time we'll introduce an ESP32S3 module with a smoother display and a more affordable price. I'm David. Bye.